We're going to talk about the types. Go support basically the different types. Let's begin. I'm just going to list them quickly. It's bool. In numeric type, it's int 8, 16, 32, and 64 and normal int. Then an int 8, 16, 32, 64, and then float 32, float 64, complex 64, complex 128. It supports byte and rune and string. So these are the ones I basically use in day to day, and there are more types which you can go forward and check on the Golang official website. We are starting with the bool. The type bool represents a boolean. It's either true or false. I'm just quickly going through all of them. So here C is assigned the value of A and B. The AND operator returns true only when both A and B are true. So in this case C should be false, right? The OR operator, you can see this OR operator returns true when either of A or B are true. So here D is assigned to true since it is true, right? Now let's just quickly run it. As you can see, A is true, B is false, C is false, and D is true. Now we are moving to signed integers. Here int 8 represents 8-bit signed integer, int 16 represents 16-bit signed integer, same for 32 and 64, and only int represents 32 or 64-bit integers depending upon the underlying platform you are using. You should generally be using int to represent integers unless there is a need to use a specific size int. So let's just quickly run it, and you can see that the value of A assigned, we can also omit this int, but just to clarify and explain the type, I'm writing it here. So in this program, A is of type int, and the type of B is inferred from the value assigned to it, which is 95. As we have stated that the size of int is 32-bit, and in 32-bit system and 64-bit in 64-bit system. So let's go ahead and let's try for the type of the variable here. So I'm just copying a code which is used for which is used for getting the type, and here the type of the variable we can print using %t, and this format specifier in printf method. So Go has a package unsafe which has the size of function which we are using here, and it returns in bytes the size of the variable passed to it. We are passing A and B here. Then unsafe package should be used with the care, as the code using it might have probability issues, and the probability issues are generally the portability issues, but for the purpose of this lecture we can use it. So let's just run it. So as you can see, the output it outputs the type and size of both variables A and B, and %t is the format specifier, and %d is used to print the size here, right? So we can infer from this output that A and B are of type int, and they are 32-bit sized 4 bytes, right? The output will vary if you run it on 64-bit system and or 32-bit system. Now there are unsigned integers as well, which are same for 8, 16-bit, 64-bit, and by default if you are just using uint, then it's 32-bit or 64-bit according to your system. Then we move to floating point. Float 32 is 32-bit floating point number, and 64 is same for 64-bit floating point number. This is the code. The type A and B is inferred from the value assigned to them. In this case, A and B are of type float 64 because I'm using 64-bit system. We add A and B and assign it to the variable sum. We subtract B from A and assign it to difference, basically the variable, and then the sum and difference is printed. Similar computation is done with number 1 and number 2 here, and let's print the output of the program. What up? So you can see that the type of A is float 64 and B is float 64, and the sum is here and the difference is here. Yeah, moving on, let's go to complex types, which are of 64-bit and 128-bit. Here they have, basically, by complex I mean imaginary and real parts of the number. The built-in function complex is used to construct a complex number with real and imaginary part. The complex function has a definition which we can just have here from here. Yeah, so it takes two variables, float types R and I, and yeah, the real and the imaginary part, basically, which are 5 and 7 in our case. Yeah, so let's just quickly run it. Okay,